All right, 12.5, volume of pyramids and cones. So we already did volume of prisms and cylinders, and if you were in class, we did a little experiment where we took a pyramid that had the exact same base as a prism and the exact same height as the same prism, and we filled our pyramid with rice, and we tried to see how many times we could fill the pyramid with rice and pour it into the prism of the same base and height, and how many it would take. Okay, and it took 3 pyramids to fill that one prism that had the same base and the same height. So when we switch to volume of pyramids, that means that it has exactly 1/3 of the same as its big B times its height. Okay, so our volume of any pyramid is going to be 1/3 the big B times H. And once again, don't forget that the big B means the area of the base. So we're going to have to do work to find that. It isn't just a single value. We're going to have to go and find the shape and decide what the shape is and what its formula is for that shape and find its area. And then the H again is the height of the pyramid, okay? And that needs to be perpendicular to the base. So one thing I do want to state there is if you think about when we found surface areas of pyramids, we use the slant height. We don't want that slant height for the volume. We want the height. We want the H from the base perpendicular up to the top spot, okay? And I say that because this very first example is not a right pyramid, but it is an oblique pyramid. But as long as we know the perpendicular height from the base to the top, we're going to be fine and we can use this formula. Okay, so I have a pyramid. I want to find its volume. So I'm going to use the equation volume equals 1/3 big B times H. But just like we did when we did surface area, we need to take a step back and say, what shape is my big B? What shape is that base? Okay, so we look here and my base is a hexagon. So when I find, and I like to write like this, base is of a hexagon, the area of the base, I'm going to do 1/2 apothem times perimeter because that's what I do for in a hexagon. Okay, on my hexagon, I'm going to draw my triangle. I always do my central angle. 360 divided by 6 is 60. Half of that is 30. So I know I have a 30, 60, 90. When I look at what I'm given right here, I know from this bottom of the space, I'm given half the side. The full side is 4, half the side is 2. That's across from my 30. That is my short. My doubled would be 4 over here across from the 90. And my long leg is 2 radical 3 across from my 60. That 2 radical 3 is my apothem. Okay, the 4 is there. We really don't need it, but it's easy to fill in. So I do have my apothem of 2 radical 3, but I also need my perimeter of the hexagon, not that triangle we just did, but the hexagon. Well, there's 6 sides on a hexagon, and each of them are 4, so 6 times 4 is 24. That gives me my big P, okay? So I'm going to multiply 1/2 times 2 radical 3 times 24. Well, 1/2 of the 2 just takes away the 2, and I get 24 radical 3 for my big B. So I have my big B. I need the height from the bottom to the top of that, and that's going to be my 10 right there. It's okay that that's an oblique pyramid as long as I have the perpendicular height. So I have the 2 things I need. I'm going to do 1/3, because the volume is 1/3, my big B, which is 24 radical 3, times my height, which is 10. Just like with the 1/2, that 1/3 gets used once. If there is a number that easily divides by 3, I like to take it like 1/3 of 24 is 8. 8 times that 10 is 80, and I get 80 radical 3, and we are in volume, so that's inches cubed for my exact answer. But I can't go in the hardware store and order 80 square root of 3 inch cubed of paint, so I need to have the decimal for that. 80 times radical 3 is about 138.5 inches cubed. Okay, so about 138.5 cubic inches. So 1/3 big B times H for the volume. Let's move on to page 2. And this is volume of a cone. Very, very similar to volume of a pyramid. If you fill a cone with water or with rice or something, and you have a cylinder that has the exact same base and the exact same height, it's going to take you 3 cones to fill that. So just like our earlier one, we're going to do 1/3 pi r squared h, because if you remember from our volume of a cylinder, it's pi r squared h, so now we're 1/3 pi r squared h. So on your formula sheet, you want to write volume of a cone, and it is 1/3 pi r squared h. And this works for all of them. We don't have to worry. All cones have the same thing. And once again, I'm going to stress this again, your height must be perpendicular to the base. Don't use your slant height. That was for surface area. Make sure you're using the height that goes perpendicular from the base or the circle at the bottom or top, wherever it is, to the vertex of the cone. All right, where possible, we like to leave it in terms of pi, but sometimes it makes no sense to leave it in terms of pi, like when they give us decimals. All right, but we'll try it. So on my first cone here, I'm finding the volume. I'm going to do 1/3 pi times my radius, which is 9.5. I'm going to square that, times my height of 16.8. Okay. We can do the math here, I guess. So we're going to do 9.5 squared. Make sure you do that first by order of operations. Then multiply by 16.8. And then divide by 3. And we get about 505.4 pi. I haven't used pi yet. And that's going to be millimeters cubed because I'm volume. That is my exact answer. Times pi itself will give me about 1,587.8 millimeters cubed. All right, second one, it's an oblique cone, but it's okay that it's oblique as long as the height is perpendicular to the base. So once again, I use the same formula, 1/3 pi r squared h. 1/3 times pi, my radius this time is 4.5. I'm going to square that times the height, which is 12. And again, watch your order of operations. Make sure 4.5 gets squared first, times your 12, divided by your 3, and I get 81 pi. That's my exact volume in feet cubed. And we want the decimal equivalent of that as well. And I get 254.5 feet cubed. Okay. All right, third page here. I have the volume of the right cone on the right. I want to find the volume. So again, I need two things. I need the radius and I need the height. It looks like I have the height, so that's not a problem. But it does look like I'm missing the radius. All right. However, they did give me this tiny angle down here of 62. I guess it's not a tiny angle. There's a tinier one. So when I think of this 62, I'm looking for this radius right here, which would be adjacent to the angle. And I already know 12, which is opposite, so I can use a little SOHCAHTOA, right? If I'm working with opposite and adjacent, that will be TOA. So the tangent of my angle 62, right, equals the opposite, which is 12, over the adjacent, which is my R. Can I solve for R when it's in the denominator? No, so I multiply both sides by R to get it out of the denominator. And then I have R times tangent 62 equals 12. I want R by itself, so I have to divide by that big chunk, and I get 12 divided by tangent of 62. Type it in your calculator. Make sure you are in degree mode when you do that. And we get a radius. Oops, I did not divide. Of about 6.4. Okay. Now remember, that's approximate, so no part of my answer is going to be exact anymore, so I'm going to be honest, you can plug it almost right in. 1/3 times pi times my radius, which is 6.4 now squared, times that height of 12. All right, let me type it in. 1/3 times pi times 6.4 squared times 12. And I'm going straight to a decimal of about 514.7. And that is in meters cubed, since I'm doing volume. All right, let's look at the one in the margin while we're here. The volume of a square pyramid is 200 cubic centimeters. Find the height of the pyramid at the side of the base is 10 centimeters cubed, or centimeters. Okay, quick visual. I have a square pyramid. Okay, I want to find, so the volume here is 200. Oops, that's going to mess me up. 200 centimeters cubed, and it's square, and one side is 10. So that means 10 by 10. Okay. Volume equals 1/3 big B times H. Okay, my big B is a square, and it's 10 times 10, so it is 100. So that's good to know that one. My volume over here is 200. My big B is 100. Oops, it's 1/3. And I'm looking for my H. All right, I really don't want to take 1/3 of 100 because it's not going to be pretty. So just like we did earlier, you can multiply by the denominator of 3. This will cancel. And I'm going to get 100 H equals 600. Divide by that 100, and H is going to be 6. And that's in centimeters. Okay, so we can work our way backwards there. All right, the volume of a composite. When we're doing volume of a composite, what I'm going to stress to you is, number one, you can add these together, and you don't have to worry about the surfaces that touch, because that surface area that you're not going to, the volume can simply be added together. Okay, so we're going to add our volumes together. It looks like I have a volume of a cylinder on the bottom and a volume of a cone on top. Okay, so when I know what I'm dealing with, I put their equations. Volume of a cylinder is pi r squared h. Volume of a cone is 1/3 pi r squared h. And now I'm ready to plug and chug. So I'm starting with the cylinder. I'm looking for its radius. The radius here is 3. I'm going to square that times the height, which is 7. All right, then I go to the cone. It's 1/3 pi. Its radius, it will also be 3 because they fit right on top of each other. It'll be squared times its height, which is 3. All right, let's do some math. 3 squared is 9, times 7 is 63 pi. And over here, 3 squared is 9, times 3 is 27, divided by 3 goes back down to 9 pi. Because both are in terms of pi, I can add those together. 63 pi plus 9 pi is 72 pi. And that's my exact answer for my volume in centimeters cubed. I can also turn that to a decimal. 72 times pi is about 226.2 centimeters cubed. All right. All right, last page, some more practice, some more examples so you can see these. Pyramid with a regular base. So it looks like I have a hexagonal pyramid right here. So I know volume equals 1/3 big B times H. I start with that, but I always need to do some side work for my big B. My big B, 1, 2, 3, 4, 5, 6, is a hexagon. And all hexagons get the 1/2 apothem times perimeter when they are right or regular polygons. Okay. Let's see. I draw my triangle. Find my central angle. 360 divided by 6 is 60. Half of that is 30. I happen to know half this side, which is going to be 4.5. That is across from the 30. So doubled would make my hypotenuse 9, and the short times radical 3 will make it 4.5 radical 3. That is going to be my apothem over there. And P is the perimeter, which is the entire base added together. There are 6 sides of 9, which will be 54. All right. So my perimeter there is 54. I am ready to multiply. If I do 1/2 times 4.5 times 54, I'm going to get 121. Come on. We'll try this one more time. 121.5 radical 3 for my big B. So I'm going to hold that on the side. Actually, I don't need to. I'm ready to go plug and chug. So 1/3 times my big B of 121.5 radical 3. And let me not roll off the page. Times my height. My height just needs to be perpendicular. It's okay that this is oblique, so it's going to be 15. All right. I'm multiplying my outside numbers together. That radical is just going to hang on the back. So I have 1/3 times my 121.5 times my 15 is going to be about 607.5 radical 3, and my units are centimeters cubed. As a decimal, because that's the exact answer, even though it has a decimal in it, that's the exact answer. is going to be about 1052.2 centimeters cubed as an approximate decimal there. All right, moving on to this right cone. On a cone, to be honest, whether right or oblique, they have the same equations. Volume equals 1/3 pi r squared h. So I'm looking here. I have a radius of 6, but I'm missing the perpendicular height. This is the slant height. I need the height, okay? So this is where I need to look and go, well, I have a right triangle. So if I do a little a squared plus b squared equals c squared, c would be across from the right angle. That's the 10. I have a 6 and an h that I'm looking for. 6 squared is 36. 10 squared is 100. 100 minus that 36 gives me 64. Take the square root, and I get a height of 8. I don't know why this is being so finicky today. All right, now I can plug it in over here. All right, 6 squared is 36. Divided by 3 is 12. Times 8 is 96 pi. That's my exact answer in feet cubed. I can go ahead and get the decimal for that. And I get about 301.6 feet cubed. All right, another right cone here for number 3. Volume equals 1/3 pi r squared h. It looks like my diameter is 14, so that means my r over here is 7. Okay. So I have 7 squared, but I need a height. I'm missing the height right here. However, I have this nice angle of 32, and it's a right triangle. So opposite that 32 is my radius. This side I'm looking for is my adjacent. Looks like I'm going to do a little TOA work on the side. Tangent of 32 degrees equals its opposite, which is that radius of 7 over my height. Can't solve for h when it's in the denominator, so I multiply by it. I have h times tangent of 32 degrees equals 7. I need to get h by itself, so I'm going to divide by tangent of 32. All right, make sure your calculator's in degree mode. 7 divided by tangent of 32, and I get about 11.2. All right. Ready to let the calculator do the work. Nothing about this is going to be exact since I had to round on that height, so I'm not even going to worry about a pi answer. So I have 1/3 times pi times my 7 squared times 11.2, and my decimal comes out to about 574.7, and that will be in yards cubed for my volume. All right, last one, this composite solid. I like composite solids. I like them when they're added together. I like when they're taken apart. I will say on this one, just for ease and because I don't know why they do this to us. Let's change these measurements to 6 on each of these, okay? I really don't want to use a decimal because it makes it so much harder. Okay, and I'd like you to get the concept, not be stressed over the numbers. What's happening on this composite solid? Looks like I started with a cube, and then I drilled out a cone, okay? Kind of took out a cone there for whatever part I'm making. So when I'm finding the volume of a cube, you can think of it as side cubed, right? Or length times width times height, all the same. And then I'm going to subtract the cone, which is 1/3 pi times r squared. All right, for my cube, I have 6 times 6 times 6, or 216, however you want to look at that. No, it's not. Yes, it is. All right. And then for my cone, 1/3 pi times my radius. Well, the 6 goes all the way across, so my radius is going to be 3. I forgot my h up there, didn't I? And my height goes from top to bottom, so it's also going to be 6, the same as the box from before. All right, 3 squared is 9. 9 divided by 3 is 3 times 6 is 18 pi. This is my exact volume, 216 minus 18 pi. when I subtract those on my calculator, I get about 159.5, and that's going to be in meters cubed. So my exact includes the pi answer, and my decimal is an approximate. All right, so that's volume of pyramids and cones. Remember, 1/3 when you do those. All right, let me know if you have any questions.